Good afternoon, students, teachers, and other committees. Welcome to my presentations. My name is PICHAMON RUNGRUANGYANGYUEN from Samsen Vidyalai School. And today I would like to present my science project called AI-powered Parkinson disease assessment system using EEG and voice analysis. So first, let's start with introductions and problem statements. As society is entering an aging era, the numbers of patients with neurological disease is continually increasing. Therefore, there is a growing need for diagnostic tools that are more accurate than visual observations and can be used at home. This is especially important because many elder people don't have caregivers or face difficulties in traveling to hospital. And then next, I will show you the method. First step is data collecting features. The system uses two types of data. First is EEG data is processing using Valve transform to abstract features, for example, EA, ED1, and ED2. Second is voice features. Voice data is analyzing using features including jitter, shimmer, HNR, MFCC, and voice complexity measure. In total, the system uses more than 50 features. Second is data pre-processing. The system applies feature selections and split the data into 80% training and 20% testing. Then standardization is applied to ensure all features have zero mean and unit variance. Finally, PCA reduced the features from 50 features into 30 components to reduce complexities and overfittings. Next is model training. The system uses three AI models. First is random forest, which uses multiple decision tree and majority votings. Second is gradient boosting classifiers, which learn sequentially from previous error. Third is neural network, with multiple hidden layers and soft math output for 7 classes start from 0 to 6. And 4 is assemble predictions. For new patients' data, each model predicts class probabilities. The results are combined using a weight assemble method to produce final predict classes and confidences. 5 is severities calculations. For the formula is severities percent is equal predicted classes divided by 6 and times 100. For example, class C corresponds to 50%, indicating a moderate severity level. 6 is real-time display. Finally, the system displays results in a real-time. Data is read from a CSV file, processing by AI model, and updated on a GUI every 100 milliseconds, including predicted classes, confidence, severity percentage, and graph. And this one is the overall system process. In conclusions, we successfully developed an AI-powered Parkinson disease assessment system with 93.5% accuracy with real-time classifications and Thai language support. Further features outlook. In the features, this system can be expanded into mobile applications integrated with wearable devices and extend to support multiple neurological diseases. This one is the challenge and appliance. First is class imbalance. Second is feature redundancy. Third is model overfittings. Fourth is real-time performance. 5 is dataset limitations. This one is references.
Very much for a nice talk. So actually with this system, can you predict Parkinson's disease, or can you just assess the progress of the disease? What do you think?
This is a predictors for Parkinson's diseases. As I said before, it is 7 classes start from 0 to 6. It is a severity level, and for my project, it can show that which class they are. from the trends before.
So you developed this AI-powered Parkinson's disease assessment system with a 93.5% accuracy.
Yes.
So how big was your sample size when determining this accuracy?
I got a sample from a CACO's it's a website that collects the gather of the data sets from science. Because of the permissions, I cannot use the real patient's data, so I use the data from it. So it is reliable, and most like research in Thailand use it also. So it's some type of big data. We use only two types of data, is EEG and the voice analysis. But when we collect the data and you put in my file, there are for about 30 components is necessary to bring us to the result.
Okay, so the patient with Parkinson's disease have some behavior deficit like tremor. So how early the disease can be detected using this AI-powered system?
This AI power is updated for 100 milliseconds. Actually, for only about 3 to 5 minutes from the data, it can reliable show the results.
So even before the person developed the symptom, this technique can detect the potential risk of Parkinson's disease early enough?
We could basically find out that we are suspected to be Parkinson's diseases or not for our actions. And if you have the suspected, you can use it. It will more clearly that you are or not.
Is there a specific brain abnormal brain activity compared to other neurodegenerative disease? Because can this device really distinguish Parkinson's disease from other neurodegenerative disease? So can it really just distinguish normal or abnormal, or it can specifically identify Parkinson's disease based on the EEG measurement?
To be honest, my model is trained by AI. We use like the data sets first, and we include it into the CSV file, and the AI will learn from it. They will learn the trends of the graph, like if he was a Parkinson's disease, in which severities, and it will show us the trend, and we will train the AI from that, and it will show out the trends. So you can like put your data set on it. It's not like some kind of formula. It's just learn from the AI trends from the graph of like Parkinson's diseases patients from before. Is that clear or?
So I mean, okay, just normal person can also use this system, right?
Yes.
So if there is a really very initial stage of Parkinson's, it can also detect, right? Because it can be also used for early detection for Parkinson's, right?
Yes, everyone can use it except
Right.
you be or not be the Parkinson's diseases.
So I'm also wondering, is this brain abnormal activity in Parkinson's very different, very specific compared to other neurodegenerative disease? So can this system can distinguish such signal from other type of disease and Parkinson's signal?
The difference from other disease, right? To be honest, it's a future plan for me to including other diseases, but we didn't learn it before. Is the difference or not? But actually, we separate the diseases. We have the type box to select which disease you suspected, and it will read from yours.
Yeah, just one question. This is you mentioned that more than 90% accuracy. It is very interesting. But my question is, what kind of accuracy? The diagnosis of Parkinson's disease accuracy, or to predict the disease process accuracy?
It's the accuracy is including be or not be a Parkinson diseases and their severity classes. Thank you. By the way, this project is already done. And in the QR code from poster, you will see how to use it and the example of using it.